Hey y'all, you should be watching this video. It's going to be, let's see, September 18th, Thursday. I have no idea what I'm doing. I'm just doing a Loom video, and if you guys could watch this bad boy, that should hopefully help you out with the work that you're going to be doing today in Algebra. So I'm going to go through about 3 different pages of material. You can go at super fast speed or whatnot. The first 2, it's one going to be easy, one's going to be hard. The next one is really just one question, and then I did a couple towards the end in terms of standard form. So for that worksheet, before you guys snag that, I would watch this one through to the end. So I want to quickly go through it. The first 2 questions are to determine the equation of a line given 2 different points. So there's 2 formulas that you need to be comfortable with for the top. The first is going to be the slope formula, y2 minus y1 divided by x2 minus x1. And the slope-intercept form is going to be y equals mx plus b, and that is the world's worst m. But anyway, so those 2 different formats, you're going to start by finding the slope of the 2 points, and they're going to dovetail over to the y equals mx plus b, or slope-intercept form. If you're struggle busing it, I'd highly recommend to label these points x1, y1, x2, y2. If you know exactly where they go, toss those into the formula. And again, if you're struggling, I see my y2 is labeled as 9, so that's what's going to go to the top left. I always like to use parentheses, especially if there's negatives involved in the terms. 5 and for y1. x2 for the bottom, it's going to start with a 5, and then finish off with a 3. That right there might take you some time, and especially if it's a complex result, if it's a fraction that needs to be reducible, you need to simplify it, but take your time, just make sure that you don't screw up at the beginning. Anything you make mistake-wise at the beginning, it kind of causes problems because the rest of it fails. So 4 over 2 is my slope, but at that point, sliding down, I'm going to identify it really as a 2 or a 2 over 1, and I'm not sure why my head is in that location. I'll go up there. Okay, at that point, you have to select one of the 2 different points. I always just simply grab the point that I find to be easiest for me, so I'm going to grab this point here and utilize that value for my equation. You are not allowed to use both points. You get to select one or the other. They both give you the same value in terms of the b or the y-intercept at the end of the equation, so pick the one that's easiest for you. Smaller numbers, less negatives, whatever you feel like it. All right, so those are my 3 different values I'm going to use from that slope derivation to be put into the slope-intercept form. So I'm going to go y equals mx plus b. I put in this 2 for the m, and double check that 3 is the x and the 5 is the y. Put in 3 for the x and 5 for the y, and then solve it out. Subtract the 6 from both sides. At that point then, my result should be a negative 1. So I finished the calculations. I have a slope, I have a y-intercept. Those powers combined then result in my overall result of y equals 2x minus 1. Okay, so this is a pretty standard one. You guys have all done this before because you're in Algebra 2, but if you've forgotten, that's that kind of more base model where everything kind of fits, kind of plays nice in the sandbox. Scrolling down, this is the one that's a little bit more kind of heavy. So this one here requires a little bit more finesse. So you have to be a little bit more kind of patient or careful. Again, more with the labeling. Pause the video if you want to give these a shot before I run through it. -8 and 6, 7, 1. Now at this point, you can quickly see that this one's going to be quite a bit more nasty. It looks like a -14 for the top and a +6 for the bottom. You need to reduce these. Do not put them into mixed numbers. They need to remain as an improper fraction if it's big on top, but I would like you to reduce it so it is -7 over 3. And just like before then, now I'm going to move on and I'm going to select the value or the point that I find to be easiest. Again, it's the first point, but 1, 6 just feels gentler than 7, -8. So I'll toss those together into the slope-intercept form to determine the overall equation that would pass through those 2 different points. So y equals mx plus b. The slope is pretty tough, -7/3. The point itself is 1 for x and 6 for y. And it depends on kind of your comfort level. So some of you guys I've talked to, you like to put a 1 underneath and multiply straight across. If you don't need to do that, that's fine. But either way, I want you to start from the right and move to the left of the equation, meaning I want you to have the -7/3 on the right side. Slow down the video and watch carefully. This 6 needs to be then converted into a fraction with the same denominator. To do so, make sure that it's actually a fraction, so over 1. Then you're going to multiply the value that's going to match this denominator we want to achieve. So I want this one to be a 3, so I'm going to multiply the bottom by 3, but then I will also multiply the top by 3. Both of the values, because 3 divided by 3 is 1, so I'm not changing the value, just changing the look of the fraction. And that 3 over 6 becomes 18 over 3. Now I'm allowed to move those fractions across. Do not change the 7/3 into a mixed number. I want those to stay as fractions to get in the habit of it. Add the 7/3 to both sides. I have the b value, and 18 and 7 is pretty tough. It looks like 25 over 3. At that point, one more time, I have the slope and I have the y-intercept. And I'll write the final result with those written together as negative 7/3 x, it's a 3, and 25/3. So it's a little bit more complex, a little bit more robust. Really, the trouble is going to come in right about here, I've noticed for a lot of students historically. Take time to really analyze these two fractions as they come out. Set this one stage first, then come back in and process what do I have to do to this one to make that 6 interact well. So that's the slope-intercept work for 2 different points. So again, let's move on. The next idea I want to be able to achieve is to work with what's referred to as standard form. This is an excellent form that we can graph with quite quickly. So I just randomly came up with 2x plus 3y equals 6. That is in standard form, which we write as ax plus by equals c. Again, ax plus by equals c, where most of us are living in the planet of y equals mx plus b land for linear functions. Standard form is just a different style of form that we're going to want you to be comfortable with. So how do you find the x-intercept? If I want the x-intercept, the y has to be set equal to 0. I need that number. If I want the y-intercept, the opposite variable has to be set equal to 0. So if I want the y, then I have to set the x equal to 0. So I'm looking for that number. This then will allow us to graph quickly these types of functions. So what you do, it's really complicated. You take your equation and you put a 0 in for the y. Oftentimes I just cover take my finger and I cover it up and I say 2x equals 6, so therefore x is equal to 3. But for this video, I'll be all fancy. I'll actually put a 0 in, cancel out the 3 and the 0. Therefore, x is equal to 3. Now, technically, x equals 3 is a vertical line, so really you should be writing it as the x-intercept is 3, 0. Get in the habit of doing that. Don't be the kid that just writes x equals 3 because it's technically incorrect. Moving on, 2x plus 3y equals 6. This time I'll cover up the 2x. That term falls away. You can see obviously the y becomes 2. A lot of people like this technique because it allows you to achieve a lot of results and you're really not doing a ton of calculations. Mostly what you're doing is just taking your finger and covering stuff up. So therefore the value is 2. Now I selected this on purpose for the video to make it really easy. So therefore the y-intercept is 0, 2. I did that. It's only because it matches here that it's so simple. If that 6 was a 12 or an 18 or a 24, those numbers would not match up correctly with the opposite coefficient. So that's just a coincidence. Okay, now to graph this out, it's pretty tough. You take these two dots and you plot them. Myar and myar myar. And I connect the dots. It's pretty tough, as you can clearly see. It takes a really long time. People like this value. Now, if these intercepts were pretty nasty, if they were pretty complex, then I'd probably gravitate towards graphing with the slope-intercept form, but it's not a bad one here. I want you to try that on the homework as well. Finally, how do you convert between standard form to slope-intercept? You need to isolate the y value. Subtract the 2x term, or whatever x term you have in the equation. Divide by 3. And make sure you remember that you're distributing that 3 from both terms. So the 2x and the 6 get tacked with a division by 3. Clean up any fractions that need to be cleaned up and processed. So really, which is a negative 2/3 x plus 2, which clearly from my background with slope-intercept, that is exactly what the picture looks like from our background. Y-intercept 2, down, over, 2, and 3. Okay, so that's the second thing we need to be able to be proficient at, standard form. And lastly, for today's purposes, input-output table and a slope-intercept to standard. So we've gone from one to the other. Now we're just getting back home again. How do you convert this to a standard form? Which again, y equals mx plus b to the ax plus by equals c. Pretty tough. You subtract the x term over so it looks like standard form. Yikes. That's impossibly hard. That's it. So if it's all just upstairs, you just simply shift things around. Typically it's done by either addition or subtraction, but it should only take you a momentito to kind of calculate that out. If it's a fraction like you see in number 2, this is where it gets a little bit kind of more wonky. You need to clear the denominator, or you'll multiply everything so the denominator does not exist other than 1. Or in this case, multiply everything by 7. 7 to u, 7 to u, 7 to u. So the next line becomes 7y. The 7's will fall away, exposing just 5x, and you have yourself a 14. Once you have all the terms upstairs, really you're back down to the exact same situation. Shift things around so that you actually have an ax plus by equals c. This time it'll be a little bit kind of fancy. I'll move the constant term to the left. Whoops, forgot u. And subtract the 7y. If you wanted to put the other side in and have it a negative 5x, positive 7y, and a negative 14, no one's going to judge you. It all needs to be upstairs, only coefficients upstairs, only coefficients of 1 down below, and it goes x, then a y, then a constant. So that's standard form. The very last one. Let's do an input-output table for standard form. How would you do that? The short answer is you don't. Those things are ugly. Because really what you want to do is you want to ascertain a function based on a variable, usually x. So you rewrite the sucker in terms of x so it's easier to do the work. So I'm going to change this standard form equation to a slope-intercept form equation. Same relationship, but it's just easier to work with, so you might as well convert. Do you have to do this? No. Is it easier? Yep, it is. If you end up not converting, you're going to end up putting those values in every single time and then solving for your y variable every time you do it. It's just simply a lot of work. So I prefer you do it this way. Now you're going to throw those terms in. I'm going to put in a negative 3. And this should feel, that's a 5. This should feel a lot like some of the work that we did earlier last week. So it looks like this is going to get ugly, a negative 6 over 5. My goodness, that is awfully ugly. Did I do that wrong? No, my brain's still there. Negative 6 over 5. I still have that bad boy, but I don't really like that version of it, and so I'm going to add a 4 to it. However, the 4 really needs to have a 5 in the denominator, so I'm going to rewrite this as 20 over 5. Therefore, I can still continue to add those fractions together. I would very much prefer to have it as the 14/5 of the result. If you want to do something where you say 2 and 4/5, that's okay. Try not to then dovetail into a calculator. Don't be the kiddo that just simply says 2.8. Try to keep in the moment of having that fraction stay alive with us. The next one, equally as challenging. You put a 0 in. That's pretty tough. And finally, the last one more time for Fraction City. 2/5 with a 7. 14 over 5. But one more time, I have that issue where I do not want to have a mixed number kind of getting concentrated with an improper. So I'm going to change that 4 over 1 to make it 20 over 5, and then finish it off with a 34 over 5. You could also put 6 and 4/5. I don't like that as much. Try to stay away from 6.8. All right, you have slope-intercept from 2 points. You have standard form graphing it. You have conversions between the two forms, and I have an input-output table. I will see you on Monday. Hopefully this video works. Hopefully it wasn't the worst one. It was the first one. 13 minutes. I do double time. All right, bye guys.